Hi everyone, so before we start this video I'm going to assume that you've all watched the previous video entitled Vectors and Scalars. If you've not watched that video, go back and watch that video and then this one will make a whole lot more sense. Okay. For now, what we are going to look at is we're going to look at resolving vectors at right angles. So we're going to be dealing with right angle triangles, which means we're going to need a couple of things from maths that you may or may not have loved. First things first, we need to remember Pythagoras. Okay, so when you have a right angle triangle, you have three sides, the hypotenuse and two others, and the size of the hypotenuse, which I've got labelled as A here, okay, is equal to the squares of the other two sides added together, and then you square root it to get A. Okay, so we're going to be using Pythagoras Theorem, and we're also going to be using trigonometry. So we're going to be dealing with SOHCAHTOA to work it out. Now, I tend to use tan more than any of the others in this, but I'll explain why when we get to a question. So we are going to be solving problems using these two equations. Okay, so let's take a look at our first example and get stuck right in. So we have a boy who's walking 3 meters north and then 4 meters east, and by scale diagram or otherwise calculate the boy's displacement from his starting position. Now you remember from the last video that we said displacement was your distance from your starting point, not the actual distance that you've travelled. Okay, in this case, if we were to think about the distance the boy travelled, his distance would be 7 meters because he's travelled the 3 and then the 4. Okay, but his displacement is this other side A that we have to calculate. Okay, and so as I said, we're going to be using Pythagoras because we have got a right angle triangle here, and so our Pythagoras gives us A squared is equal to B squared plus C squared, and so A is equal to the square root of B squared plus C squared. I'm going to put in my values now, and so it's going to be A is equal to the square root of 3 squared plus 4 squared. I'm going to put that in my calculator and it's going to come out as 5 meters. Now, as I said, that would be our displacement, but displacement is a vector, and from the previous video you remember that vectors have a direction as well. Okay, and so this is where we're going to start looking at how we work out the direction. Now, in questions like this, all of our directions are dealt with as bearings, okay? And all bearings work from north. So it's always really important that you put on where your north line is. And this question's a little bit easier because you started from walking north. So in order to work out his direction, you just need to find this angle X, okay? And so to use that, we're going to use our trigonometry. SOHCAHTOA. Now, because you've worked out the hypotenuse, A, in your first part of this question here, you could theoretically use any of those three relationships. But because in the question it gave you the opposite and the adjacent, my preference is to use tan, because then you're using numbers that were given to you in the question, not one that you may have made a mistake in finding. Okay? And that way your answer for this section will be bigger. It will be more likely to be correct than if you'd used the wrong number. Okay, so our equation here, tan of x is equal to opposite over adjacent, and so x is equal to tan to the minus 1 of opposite being 4, adjacent being 3. And then what you're going to do with that is you're going to pop it in a calculator. That's 53 degrees. Okay, so that means that our value here for x is 53 degrees. Now, in order to convert that into a bearing, okay, we have to consider everything as travelling from north. Okay, now if you look at a compass, we have north up here, and then we have east, south, west. Okay, now north is considered to be 0, 0, 0, east 0, 9, 0, south 180 and west 270. Okay, each in 90-degree blocks. So if we have 53 degrees, it means we're up in here going in that direction. And to write that as a bearing, okay, that 53 degrees would become a bearing of 053. Okay, 053. So our final answer then for this question is that the displacement of the boy, S, is equal to 5 meters at a bearing of 053. And we have to have a wee degree sign up there. Okay, so 5 meters at a bearing of 053 degrees. Okay, we're going to go on to a second question. This time there's no triangle pre-drawn for us. Okay, so a motorcycle drives 600 meters west and then 1.2 kilometers south. Okay, calculate the displacement of the motorcycle. Okay, so he's gone 600 meters west. And then 1.2 kilometers south. I'm going to write 1.2 kilometers as 1,200 meters. Okay, and so that gives us our displacement being the connection of those two there. Okay, all vectors are joined tip to tail, so you'll notice that the tip of the 600 meets the tail of the 1,200, and then we connected the tail of the 600 to the tip of the 1,200 to find our displacement, okay, which we're going to again call A. So calculating A squared is equal to B squared plus C squared. Okay, so A is the square root of 600 squared plus 1,200 squared. You pop that in your calculator and you'll be able to get a nice easy answer to use of 1,342, I'm going to round it to 1,342 meters. But again, that's not our final answer because we need to use our trig to work out our angle. Okay, now in this one, what you can work out is this angle here, which we're going to label X. But that's not going to be the final angle we can use for our vector, because all bearings have to start from north, and north is that way. So in order to get this right, we need the angle on the other side. I'm going to give it a different colour again. Here we go. So we need this angle here, round this side all the way around. So that big one. Now you might have noticed that what we can then do in order to get that is we can work out the value of X, and then because this line is going west, we know that it is 270 degrees. So we can do 270 minus X will give us our bearing. Okay, so first things first, work out our value for X. So tan of X is opposite over adjacent. Okay, so X is tan to the minus 1 of 1,200 over 600. Okay, and that's going to come out as 63 degrees. And so our final bearing is going to be 270 minus 63 degrees. So that's going to come out as 207. And so our final displacement for this question, for our motorbike, would be S equals 1,342 meters at 207 degrees. Okay. Again, there's going to be some questions on a worksheet. I'll put a link in the description below for the worksheet if you want to give it a shot. Good luck.